And welcome back. Just a beginning of a second video in this series. As you can see, we're still progressing on getting the battery system replaced with these newer series of cells, which are, at least this particular pack is now in what you would consider a battery, as it's multiple 16 cells that have been put together in series. And we went ahead and just plugged in our connectors into our Anderson cables, and the other side of these Anderson cables on the negative have been hooked into our negative bus bar that you see there. They come out to these, again, big old honking cables, and what will happen is those two connectors will mate like that and then snap into place, kind of like we covered yesterday. So to show you that that's been done, those cables have been terminated. And then when we get to it, the last step will be actually connecting the negative post into the batteries. And what we've been doing here, sorry, again, the floor is still kind of littered with tools, but it is the way as you start a project. What we're doing here is that we're getting these cells hooked into series. As we just talked about before, you're going to have 16 cells in series for what they call a nominal 48 volt system. I think it actually comes up to be about 53-ish and change, if I remember correctly. But with that being said, I just want to show you our process of what I do when I'm hooking these up in series, just to make sure that I'm hooking the bus bars up in the correct order, and at least for myself, trying to be as careful as possible. And yes, you can see that, as promised in the previous video, we're working with the battery at this point. So we do have on a pair of safety glasses, here they are right here, as well as gloves. And I'm going to bring you around to the back side of this bank, as we already have the front bank almost complete. Okay, I'll show you what we're doing here. Now, as we talked about in the previous videos, this side of the battery bank is going to be where our positives come off of our packs. So you'll see I've got an alligator clip on the positive side here that goes to that meter over there. And yes, I know what you're going to say. I have a meter sitting on top of the previous battery, but just rest assured that that is a rubberized jacket coating on this meter as well. Plus I have it sitting between two terminals that would normally be hooked together, if you'll notice the bus bar. Again, not that excuses the practice, but I need a convenient place to set this, and I am aware of what it's doing and the potential there. Again, just to reiterate, this is not a how-to video. This is not saying that you need to do your system exactly this way. This is more documenting the process of how we're doing and why we're doing it. Maybe it'll be helpful for somebody. Maybe it'll give you an idea. Maybe it'll give you an example of what not to do. But like I said, we'll get there. But as we said previously, we're hooking these batteries in series. So now you'll notice the batteries have already been reassembled after they've been top balanced, and they're alternating. So you'll see a positive post here, negative post here, positive here, negative here, positive here, negative here, on down the line. We did that. We checked it 3 or 4 times in a row just to verify and absolutely make sure that our orientation going down this lane is exactly the way we wanted it. In other words, being correct. Now, when we're connecting these batteries together, we are looking, in this case, to connect. Since this will be our main positive, it's not going to have a mate. It's going to go off and go into that Anderson connector and eventually end up in our positive bus bar after it goes through a fuse, but we've covered that already in a previous video. So we're looking at going, since this is a positive, this negative to the next cell's positive. So negative, positive, negative, positive, negative, positive, negative, positive. And we're repeating that. So we're taking this step further, and just being a little bit extra cautious is that as we add a battery in, remember, since positive's on that end and we're putting a series bank of 16 cells together, every time I make a connection, I'm testing it with a meter. So you can see the meter says we're at 30 volts at this point in time, and we're 9 batteries in to this connection. So I know when I apply my bus bar, my next bus bar is going to go from this test point I just tested here, which is battery 9, this negative to this positive. Therefore, my test lead should always be hitting a negative. So if I'm connecting my batteries, and you wouldn't want to do this, you'd know right away, if you're connecting your next cell and you see a negative here and a negative here, you know this cell's in the wrong orientation. Something's wrong. You need to stop. So in my case, my next bus bar is going to go from, again, cell 9 negative to cell 10 positive, which again leaves me a negative on cell 10. Now, if I probe it, you'll see millivolts in there because it's not actually connected to the rest of the pack, not yet. So I'm just going to reach over here and grab a bus bar. There we go. So again, negative, positive. Like we talked about earlier, I'm going to flip this around. Just my preference. Some of these bus bars seem to be a bit smoother on one side versus the other, so that's why I flipped that. The negative to positive. Now I don't have the screws in here, so it's not the world's greatest connection, but I'm just testing voltage at this point. So negative, positive. So now if I probe the negative on cell 10, we're at 33.5 volts, and so on and so forth. So just to give you an example of when you're connecting your cells together, check, double check, triple check, quadruple check. Make sure that it is what you expect. So again, we've connected cell 10. The next connection will be 10 to 11. Once again, we know that when we're going to test this, we're looking for a negative test point in this setup. So our bus bar, in order to do that, is going to have to go from this negative to this positive, joining these two together, again, leaving us our negative test point. We'll test battery 10. And we'll do this on down the line until we get to cell number 16 and verify that we've got the pack voltage that we expect. Now, coming back to the front of these cells, and we have the first pack almost wired in here. You can see that we got our main positive connector, which goes down to our Anderson plug that we talked about in the previous video. Now, watching Lithium Solar's current video, I shouldn't say current video, but his video where he has his EVE 280 cells configured and getting ready to put them in service. The last video I watched, he got the Batrium monitor installed. He made a very valid point about these screws that come with these batteries, and I've got one right here to show you. And once again, hopefully you can see that the backs of these nuts have this serrated edge on them, so they act as a washer and a lock washer at the same time, but that serrated edge is meant to actually bite into that bus bar. So when he was hooking up his Batrium, as far as the cell monitors were concerned, in his video he drilled and tapped a hole in the bus bar to attach the wires to. Now in my setup, as we spoke about before, we're using long mon battery monitors that you can see have been affixed to the front of every cell to include the back bank there. Now what I decided to do was taking Lithium Solar's advice, and you'll notice that these positive and negative connections that go into these long mons, and it has one on each cell. That's how each long mon can monitor the health of each individual cell. Rather than take that eyelet connector and put it flat against the bus bar and then put the nut on top, causing it to where that nut may not engage or seat fully because of that eyelet connector, we have the bus bar screwed down with the first nut that you see there, and then in between, because there was enough thread left over on that little grub or set screw, that little Allen stud they have sitting there, we put the ring terminal for the long mons on it, and then went out and bought more of these, and these are M6. Let me grab the box for you. And I believe I got these off of Amazon. Hopefully you can see that. These are, in fact, M6 304 stainless steel serrated flange hex lock nuts, as they call them. These came 26 to a carton. And so what we've done, which are basically, they're the same serrated flange nuts that come with the batteries, and then we put another one on top. So it's kind of a long-winded way of saying that these eyelets are sitting sandwiched in between two of these flange nuts. So that way it allows it a good connection to see the cell, and it also allows the bus bar a good connection with the top of this battery without having an extra piece of material that might interfere with that connection. And that's how we chose to handle it in our case. And you can see each one of these cells has that going down the board, and we'll repeat the process over there. So that's where we sit right now. Again, we're making progress of getting all our wiring done and getting all this tied down. It's, like I said, it's a bit of a process, especially when you are doing what we're doing in decommissioning and basically redesigning this entire battery bank. But we'll bring you back when we get to the next step. Thank you much. And welcome back. Just want to show you that we've got our long mons wired at this point, and per the instructions, they're just daisy chained and connected into each other. Not to make this a Batrium video, but just kind of go over the overview of it. The long mons basically talk in one big daisy chain to and from the Watchmon controller that you see on the wall there, and I believe that is the Watchmon 4 with the expansion module next to it. Now, normally the Watchmon in our case is powered off an isolated DC to DC power supply, which gets its power from the battery bank and gives you two 24-volt outputs. Just for the sake of getting the long mons updated, getting the changes made so that the Watchmon no longer looks for a 64 cell system but a 32 cell system, we're going to we're actually powered just off the USB port that you can see there. Meanwhile, everything else is still off. Charge controllers are off, inverters off. As you can see, the battery banks are completely disconnected. They're not even tied into each other at this point. This is strictly just to get the Watchmons, long mons updated with the Watchmon controller. Now, the way this works is that you'll see the isolator block here, and that comes, it kind of starts with a an out port, which is a 4-pin port, comes down around, comes over here and hits the first cell, which means it's going to end up plugging into here, which I haven't done yet, but I will do here shortly. And then it will daisy chain from a 2-pin to a 4-pin, 2-pin, 4-pin, 2-pin, 4-pin, 2-pin. The reason why they're all green right now is because they've been plugged in for the first time since they've been shut off, and it's just kind of a default mode. It allows you to at least verify that you've gotten power hooked up to this cell correctly into this long mon. I'm going to grab that cable now. And what these are is that we've just extended the cable that comes with the Watchmons. Like, this is the typical length of cable where it comes from a 4-pin connector down to a 2-pin connector, and the 4-pin connector is what has the power that connects, that the long mon's using in this case to monitor the cell power. And it literally, you'll see this on the Batrium's adapter. What we've done per their instructions is just use some category 5 patch cable, some twisted pair cable, and just extended it out. So that way what's going to happen, and go ahead and get this plugged into this first long mon here. There we go. And this makes this, basically the way I have it wired, is that this makes this cell number 1. And then through 16, cell 17, then starts here and goes all the way down to 32. So with that being done, I'm going to plug this isomon back in. There we go. I'm going to come down into their software and do a device sync, because I've already updated the Batrium software to only need to look at the last cell ID as a 32 instead of a 64. And you can actually see here that the minute I plug that back in, it actually sees 32 on its own. And right now it's seeing which would be about 2 millivolt difference between the highest and lowest cell. But we're going to run a device sync to get those changes pushed out to the long mons. One moment, I gotta get my pin number. And apologies for the camera work here. And you can see it running there. And if you look at the long mons, eventually, see that red flash? There they go. You'll see some activity as they're going through. And you can probably hear the watch mon clicking. There we go. Now you'll notice they went from a solid green to just kind of a chase type flash of that green LED. And down here on our screen, and this is probably showing up horribly, but you'll see that it says success, device is in sync. So we're going to go back to our chart. Perfect. Let's see what else we got going on down here. Okay, now you see we still have a fault. It says low shunt voltage because again the packs are disconnected at this point. All we have right now is just the watchmon running off of a laptop and literally just hooked up to the cells themselves. So we're bouncing anywhere between a 1 and 2 millivolt difference between the highest cell and the lowest cell. Awesome. Okay, that is one more step done. We're going to continue to work on getting these cells at least hooked into the bus bars so that they can see each other. And then I'll bring it back when we do that one. There's one, even though we have top balanced these cells, and these 64 cells were hooked in parallel with each other for the better part of about 2 weeks. I'll show you what I normally do when I'm adding a new bank of cells into an existing bank. Same trick we did when we did the top balance. We'll hook up the negative, and then normally down here where you see the fuse block is like I'll hook an amp meter in between that and basically allow it to flow through the meter, and if I see an excessive amount of current flow, then I'll back off and see whether it's a case where the new pack is just a higher state of charge or maybe a lower state of charge to the existing one. But if I see something along the lines of 20 milliamps or lower, then I'll leave it connected through the meter as a means of protection until the two packs balance out with each other, and then go from there. Now, since they are hooked up to the Batrium, there's a couple of different ways you can do that. If you want, you can alter the settings on this Batrium for these long mons, and let's say that the lowest cell is maybe 3.1 volts and everybody else is higher. You could change the bypass voltage on these long mons to be 3.1 volts as a custom setting. Push that out, and then what that will do is it'll start putting these long mons into bypass mode, meaning it'll put up to a 2 amp load per cell and drag all the cells down and keep discharging them until everybody hits that new setting. That's kind of one of the ways you can bring all the cells together to get them at that same level. And like I said, there's several different ways you can do it. It's one of the ways I've done it in the past. But I'm going to get one of these banks hooked into the bus bars. And then when we get ready to hook the second bank into the bus bars, we'll bring you back. And welcome back. I just want to show you that we do have the first battery bank hooked into the main bus bars, and the Batrium software is seeing it. You'll see that the Batrium sees a 53.89 to 90 volts. We're reading a 1 to 2 millivolt deviation between highest and lowest cell. Keep in mind what you're seeing is all 32 cells, even though the first 16 are the only ones currently attached to the main bus bars. So what we're going to do now is we're going to attach in that second bank. And you can see that the Anderson plugs for the negative side of each pack are already connected. What I wanted to show you is that nice solid thud you get from plugging in one of these Anderson connectors, excuse me, and put my glove on. Just one moment. Now, you'll also notice that the Class T fuse holder is currently empty. So it's safe for me to plug this in. There'll be literally no potential on it at all. Just to show you here. There you go. Nice solid click. So far, I'm liking them. Time will tell what they look like overall. Pardons for the camera getting swamped out with the stick light there. But what I wanted to show you was that usually my process for adding a new bank of batteries into an existing bank. Now, once they've been top balanced, however method you choose, as close as you can, what I normally like to do, just as a safety precaution, just like we've done in our previous videos, when we were adding each cell in parallel for the initial top balance, is that I like to use my meter. Put my meter in amp mode because the meter is fuse protected up to 10 amps, and it can break the short current or the current capable of these cells. Ask me how I know, trust me. Which brings me to a good point of reference. Whenever you use at least this particular meter in amp mode, you'll notice that the red plug down there is currently plugged into the A side, meaning amps. Whenever you get done and you want to use your meter back for using volts again, make sure you take that red plug and move it back over to the proper port for measuring volts and ohms and continuity and things of that nature. But on to what we were talking about before. So just like when we did the parallel, and excuse me, I'll put my glove back on again. And what I'm doing, in case you're wondering, is that I use a GoPro for doing this, and the screen, you know, occasionally does time out, and I like to use the little viewfinder to make sure I'm getting things in the shot. But we're currently in amp mode, and just like we're doing the cells in parallel, what I like to do is just use my meter to show me what the current draw is between the two packs, and right now it is showing 0, which means there's no potential, no voltage or current transfer between the two packs. So, which is what we expected, because again, we had the packs top balanced with each other, and then the two banks of 16, when they were top balanced, were hooked into each other for probably the better half of 2.5 to 3 weeks, and they literally showed 1 milliamp to 0 milliamp passing between the two after that time span. So this is what I'm looking for. Now, if I were to do this and I would see 2, 3, 4, 5 amps, then I would kind of go back and evaluate the state of charge of the two packs. But if I do this and I see 20 milliamps or less, I'll generally leave it connected through the meter until it hits maybe 10 amps or less, or 10 milliamps or less, and then I'll go ahead and install the fuse and leave things well enough alone. But we're seeing 0 amps of current between the two, which means they're still pretty much dead end with each other, and I'm happy with seeing that. And what we'll do is we'll go ahead and get these tied in, let them stay connected overnight. We're going to leave the solar system currently turned off, as well as the inverter, and then tomorrow when we get some sun in, then we'll start powering up the charge controllers on the inverter, and we'll get the all the settings reset to make sure our charge controllers are still set where we expect them to see for our topmost battery voltage, float settings, and things of that nature. And with that, that'll end the second part of this video. At this point in time, we've got the new cells in the battery bank. We've got the old cells officially retired and pulled, and that'll end it for this second video. And we'll bring you back as things progress, and we start to use these cells to power the inverter and power the house and charge them from solar, and we'll kind of show you how that goes, and we'll see if there's any deviation in the cell over time, and we'll let you know how all that turns out. And I'd like to thank you for taking the time to watch, and if you got any questions, please put them in the description below, and I'll talk to you later. Bye.